Hello everyone. Welcome you all for the new lecture series of control system. So previously we have discussed about few topics in the lecture series 1. It was completely about the introduction of control system. So here I am going to explain the second lecture series. It completely about the time response. I am Ramya, working as an assistant professor in SNS College of Technology in the Department of EEE. Here I'm going to explain the basic things what we have going to do in the time response. So for that, we need to know what are all the standard input signals we have and what are all the different types of input signals we are going to apply to the system. So first we have to know what is the standard test signal. So from the picture, you all know we have a system, we are giving the input and it will produce us some responses. Now we are concentrating more about this input signals, which is a test signals, and it has some standardized format. So this standard test signals are used to estimate the performance as well as the characteristics of the system so that we are analyzing the response of the signals. So these signals are applied one by one as an input to the system to determine different responses such as stability, linearity, transient response, as well as the frequency response. The four basic standard test signals we are going to discuss today in this video are step signal, ramp signal, impulse signal, and parabolic signals. Step and unit step signals. Let me explain first about this step signals. So we all know the magnitude of this step signal is a constant one, and a step signal exists only for the positive values and 0 for the negative values. So from this picture also you can able to understand this concept. That is, here we are applying the u of t, that is the magnitude, which is a constant value as a for t greater than 0, and for t less than 0 and the response will be 0 here. So it is used to analyze the system response to sudden change in the reference input. And also it is defined by its magnitude. First graph, it is represented for the step signals. So if t is greater than 0, the corresponding magnitude will have some constant value. Here we are representing it as a. If for the second step signals, we are concentrating on unit step. So make this constant value as 1, and this condition is the same for both step and as well as the unit step. Next one is ramp signal as well as the unit ramp. In this ramp signal, it is an increasing function which increases linearly with time. So from this graph, you can see if your time values is increasing, corresponding, there is a changes in the responses also. That's why we are representing R of t equal to t for t greater than or equal to 0, else R of t is 0 for t less than 0. And also it is used to analyze the system response, which is linearly changes according to its input. Next, it is also known as the velocity type input, and we can define it by its slope. So first graph represent for its ramp signal. So once the t values increases, corresponding changes will happen in the responses also. And this is for the unit ramp. Here also the R of t is t, that is this a value which becomes 1 in the unit ramp signals. Next, we are going to deal with the impulse signals. Impulse signal exists only at the 0 value. When t equal to 0, it has some uh, highest value, that is the peak values. In the graph, we can able to see that it is a infinitesimally narrow pulse with the unit area and the infinite amplitude. And it is also used to analyze the system response to the impulse. And here we are representing it as del of t, which is infinity for t equal to 0. This condition will happen only at the 0 time. So t equal to 0, when t not equal to 0, obviously the response will becomes zeros. And the last test signals will be the parabolic. The parabolic, which is the signal whose magnitude varies as square of the time. So from the graph, you can able to see that we can take the x-axis as time as same as the previous type signals, and the corresponding response here we are mentioning it as p of t. It is also called as the acceleration type input, and it is used to analyze the system response to nonlinear inputs. Here we are representing the response p of t, which is equal to p square by 2 for t greater than or equal to 0, or else t less than 0, the output response will becomes 0. So I hope you have understand. Let me recall it once again. For the step signal, it has the condition as t greater than 0, u of t will becomes 1, or else it will be 0 for t less than or equal to 0. And for ramp signal, if you are t greater than or equal to 0, there is a response that is equal to t, that is the time value. Else t less than 0, all the remaining responses will becomes 0. And we have impulse. For that, it happens only when t equal to 0. That too, it has the peak value up to its infinity value. And the parabolic, the p of t, which is equal to t square divided by 2 when t greater than or equal to 0. Else p of t is 0. Thank you.